Hello everyone, this is the specific heat laboratory tutorial. This lab will allow you to investigate the heat energy conservation and the specific heat of an unknown, well, not very unknown in this case, but of a substance. The reason why it's not unknown is because you're going to be using a simulation, but at least you're going to be able to basically replicate everything that you will be doing in a lab. Now, the results will be very ideal because in a lab, you will be using a calorimeter, a steam generator, you will be using a thermometer, and the way we will do the experiment will give you some sources of uncertainty and errors. In this simulation, you are going to basically avoid all that, which is okay because the idea is that you calculate and you do your calculations that you put into practice the concepts of specific heat capacity, calorimetry, heat, change of temperature, right? However, again, maybe the only disadvantage is that you don't have the hands-on experience, but still the concepts are in there. And in fact, this simulation will allow you to basically use a calorimeter, right? It's like if you were in the lab, you are just doing it from home. So there's a brief introduction, and the main equation you're going to be using, Q equals to mc delta T, where m is the mass in grams, C is a specific heat for the substance, in this case water, 1 calorie per gram per Celsius. So we're going to be using those units, all right? Because we're going to be working with very small masses and the change of temperature in Celsius. So then at the end, we have the units of heat in calories. So you have two parts. On the first part, you will be choosing a liquid and you will be taking the mass of it. And then you're going to make sure that this is heated up. And then you're going to be transferring to a cold liquid here. You can choose different liquids here. And then you're going to run the experiment where you're going to see when you reach the temperature of equilibrium or equilibrium temperature. Basically, is the point where the heat gained by the hot substance is equal to the heat lost by the heat lost by the hot substance is equal to the heat gained by the cold substance. If you're using water and you're combining it or mixing it with let's say hot water with cold water, then eventually they will reach an equilibrium temperature. Now, it will be more interesting when you have another element here, aluminum, for example, or copper, and it's very hot, and you place it into cold water, and then you want to see the difference in temperature, right? At the end of the day, that change on temperature depends on the specific heat of the substance. And that's the idea with this lab, to investigate that. So you have a table here. So basically, the way you should do this is you want to use water, maybe 100 grams at a temperature of, yeah, let's put it at 100. All right. You can choose the specific heat, but this is in joules per gram per kilo per Celsius. So you don't want that. You're going to be using one, so don't worry about it. And then here you want to have, next. Then here you want to have water again. And maybe here, not 115, let's put here 80 grams at room temperature 20 degrees Celsius. So now we can show the graph, and then we can run the experiment. So as you can see, the hot water is being placed into the calorimeter, and you can clearly see how the temperature of the calorimeter of the cold water at 20 degrees Celsius is increasing. And at some point, the two curves will meet, and that will be the point of equilibrium. There. So the system is at equilibrium of 64.44 degrees Celsius. So there is a change on temperature on the cold water, in the cold water, from 20 to 64.44. And there is a change in temperature from 100 to 64.44. So the hot water is losing heat and the cold water is gaining it. And the idea with the lab is to compare both. So you can go back to the lab and you can fill in this table, the mass of cold water, the initial temperature of cold water, of hot water the same, and the final temperature of the mixture, which in this case will be 64.44. The mass of foam cup, you don't need to worry about that, all right? Because again, you are not doing a lab in person. If you were doing a lab in person, you have to worry about the container. But as you can see in this lab, they don't worry about it, all right? Mass of the hot water added is basically the hot water, the same as this. The increase in temperature, the decrease in temperature, you just have to see the figures in the experiment. And then you're going to use the equation here. So basically, for the cold water, the heat gain will be the mass of cold water (80 grams) times the specific heat capacity of water, which is 1, times the change in temperature, which is 64.44 minus 20. And that will give you a value in calories. The heat loss by the hot water will be the mass of hot water, which was 100, times 1 specific heat, and then 64.44, 100 minus 64.44. Now, if you want to keep it more accurate, the heat loss should be negative. So you will do and that will give you the heat loss in negative because it's being lost. And that's it. That's part 1. Very simple. You want to compare both heats, should be the same. And that's basically for part 1. For part 2, you are going to choose a solid. So like, again, this is going to be an unknown for you, right? Use copper. Normally in the lab we use copper. So I use that. Not very massive. I would say 15 grams is good. And the temperature of, it can go to be, remember, the boiling and the fusion temperature of different substances is not the same as water. So those elements can go beyond 100 degrees Celsius. But if you were doing this in the lab, you cannot do that because the way you will do is you will place this guy inside in water and then you will boil water. So let's say that it reaches 90, okay? And then the liquid is still water. Normally for this type of experiments, you want to have like, let's put 100 grams of water. Yeah. And then the temperature of water, 20 degrees. You leave it like that. And then you start. So we're pressing the copper. We close the calorimeter. Notice how the temperature doesn't increase a lot for the water. The reason is because the specific heat of copper is way less than the specific heat capacity of water. Water is an excellent coolant for engines because of that. It doesn't get hot that easily. All right? So, or it doesn't increase its temperature that easily. So as you can see, it only went up by 0.95 degrees Celsius. So the copper lost a lot, or I decreased a lot its temperature, but the Q gain is equal to the Q loss. How come? Because the specific heat capacity of copper is, again, much less than the one of water. So at the end of the day, what you have to do to find the specific heat capacity of copper, because that's the end of part 2, is to fill in this table. You have the mass of cold water, the initial temperature, which was 20, the initial temperature of the hot metal, 90, the final temperature of the mixture, 20.95, and then the mass of the metal, it will be 15 grams. And then you will do the equations. Again, Q gain, but now you will make it equal to Q loss. What's your variable? Your variable is C. So the way you will write the equations for part 2, with the values I use, will be Q gain equals to Q loss. For the water, it was 100 times 1 times, here you will put 20.95 minus 2. And we are going to take the absolute value of Q loss because the specific capacity is going to be negative. So we use the 15 grams of copper times the C of copper, we want to find C, times the temperature change, which is going to be 90 minus 20.95. And then you solve for C. All right? That's basically what you have to do for part 2. It's a very interesting experiment, very similar to what you will do in the lab. All right. So I hope you guys have fun with this lab. If you have any questions, please send me an email. I'll be checking them, and we can always have another session online. We can go like on office hours, so we can go over any questions you may have about this lab. All right. So make sure you are following instructions and that you complete both sections of the lab. All right. Have a good rest of your day, and I will see you guys in the next tutorial.